Welcome to my third lecture on polynomials. In this lecture, we will discuss about how to form a quadratic polynomial with the given zeros and some more problems based on sum of zeros and product of zeros, that is alpha plus beta and alpha beta. First, we will see how to form polynomial from its zeros. Consider a standard quadratic polynomial ax squared plus bx plus c. Let its zeros be alpha and beta. So we write x equals alpha and x equals beta, or x minus alpha equals 0 and x minus beta equals 0. So x minus alpha and x minus beta become the two factors of the required quadratic polynomial, which will be x minus alpha multiplied by x minus beta. After simplification, it will become x squared minus alpha plus beta into x plus alpha beta. Now, by substituting the values of alpha and beta in here, we will get the required quadratic polynomial. We have to find the quadratic polynomial whose zeros are 4 and 6. Here alpha is 4 and beta is 6. The required quadratic polynomial will be x squared minus alpha plus beta into x plus alpha beta. We will substitute the values of alpha and beta. It gives us x squared minus 4 plus 6 into x plus 4 into 6, which gives us x squared minus 10x plus 24, and this is the required quadratic polynomial. Next, we have to find the quadratic polynomial whose zeros are minus 3 and 5. Here alpha is minus 3 and beta is 5. The required quadratic polynomial will be x squared minus alpha plus beta into x plus alpha beta. We will substitute the values of alpha and beta and write x squared minus 3 plus 5 plus minus 3 into 5. It gives us x squared minus 2x minus 15, which is the required quadratic polynomial. We have to find the cubic polynomial with three sets of conditions given. First, the sum of its zeros. Second, the sum of the product of its zeros taken two at a time. And third, product of its zeros as 0, minus 7 and minus 6 respectively. Here we are given alpha plus beta plus gamma equals 0, that is sum of zeros. Then alpha beta plus beta gamma plus gamma alpha equals minus 7. This is according to this second condition. And alpha beta gamma equals minus 6, which is the third set of condition, minus 6. Now we will start our solution by assuming the required cubic polynomial to be ax cubed plus bx squared plus cx plus t. We will divide throughout by a in order to make the coefficient of x cube 1 and write x cube plus b upon a x squared plus c upon a x plus d upon a. We have written the cubic polynomial as x cubed plus b upon a x squared plus c upon a x plus d upon a. For a cubic polynomial, we already know that alpha plus beta plus gamma equals minus b upon a, which in this problem is given to be 0. Therefore, minus b upon a will be 0. That is, b upon a is 0. Next, we know alpha beta plus beta gamma plus gamma alpha equals c upon a, which is given to be minus 7 in this problem. So, we write c upon a equals minus 7. Next, we also know that alpha beta gamma equals minus d upon a, which is given in this problem to be minus 6. So, we write minus d upon a equals minus 6. That is, d upon a equals 6. Now we will use all these three values in this cubic polynomial, which is x cubed plus b upon a x squared plus c upon a x plus d upon a. By substituting the values, we write x cubed plus 0 x squared plus minus 7 x plus 6, which gives us x cubed minus 7x plus 6, and this is the required cubic polynomial. If alpha and beta are the zeros of the polynomial ax squared plus bx plus c, then we have to form the polynomial whose zeros are 1 upon alpha and 1 upon beta. For the polynomial ax squared plus bx plus c, we have alpha plus beta equals minus b upon a and alpha beta c upon a. The new zeros given are 1 upon alpha and 1 upon beta. So the sum of zeros will be 1 upon alpha plus 1 upon beta. That will be alpha plus beta upon alpha beta. But alpha plus beta is minus b upon a and alpha beta is c upon a. So sum of zeros will be minus b upon c. For a standard quadratic polynomial, we know that sum of zeros, that is alpha plus beta, is minus b upon a, and product of zeros alpha beta is c upon a. For the new polynomial, we have just found out the sum of zeros to be minus b upon c. Now we will find out product of zeros, that is 1 upon alpha multiplied by 1 upon beta, which will be 1 upon alpha beta, but alpha beta is c upon a, so we write 1 upon c upon a. Now this a will go up here and product of zeros will be a upon c. Now the required quadratic polynomial will be x squared minus sum of zeros times x plus product of zeros. Here we will substitute the values of sum of zeros and product of zeros in order to get the new polynomial. After substituting the values, we write x squared minus b upon c, because sum of zeros is minus b upon c, times x plus product of zeros, which is a upon c, which will be x squared plus b upon c x plus a upon c. Now we will remove the denominator by multiplying throughout by c and write c times x squared plus b upon c x plus a upon c. After opening the bracket, we will find cx squared plus bx plus a, which is the required new polynomial whose zeros are 1 upon alpha and 1 upon beta. Next, if alpha and beta are the zeros of the polynomial x squared plus 4x plus 3, we have to form the quadratic polynomial whose zeros are 1 plus beta upon alpha and 1 plus alpha upon beta. For the given quadratic polynomial x squared plus 4x plus 3, sum of zeros alpha plus beta is minus b upon a. Here b is 4 and a is 1. So alpha plus beta becomes minus 4. Product of zeros alpha beta is c upon a. C is 3 and a is 1. So product of zeros alpha beta becomes 3. The new zeros given are 1 plus beta upon alpha and 1 plus alpha upon beta. So sum of these zeros will be 1 plus beta upon alpha plus 1 plus alpha upon beta. It will be 1 plus 1, 2, and sum of these two, that is beta upon alpha plus alpha upon beta. It will be 2 plus beta into beta, beta square, alpha into alpha, alpha square upon alpha beta. Next, 2 multiplied by alpha beta will be 2 alpha beta plus beta square plus alpha square upon alpha beta. Now, the expression in the numerator is a perfect square, and we can write alpha plus beta whole square for the numerator divided by alpha beta. Now we have already found out alpha plus beta equals minus 4 and alpha beta equals 3. We will substitute these values in here and get sum of these zeros equals minus 4 squared, because alpha plus beta is minus 4, divided by 3 because alpha beta is 3. So that will be 16 upon 3. So sum of these zeros is 16 upon 3. Now product of the new zeros will be 1 plus beta upon alpha multiplied by 1 plus alpha upon beta. This will be 1 times the whole bracket plus beta upon alpha times the whole bracket again. It will be 1 multiplied by 1 plus alpha upon beta will be 1 plus alpha upon beta. Beta upon alpha times 1 will be beta upon alpha, and beta upon alpha multiplied by alpha upon beta will be beta alpha upon alpha beta. So beta alpha upon alpha beta will be 1. 1 plus 1 will be 2. So we get product of the new zeros as 2 plus alpha upon beta plus beta upon alpha. But we have already found out the sum of the new zeros to be 2 plus alpha upon beta plus beta upon alpha, which we have evaluated as 16 upon 3. Therefore, sum of the zeros is same as product of the zeros, which is 16 by 3. Now, the required quadratic polynomial will be x squared minus sum of zeros times x plus product of zeros. Substituting the values, we get x squared minus 16 by 3 plus 16 by 3, which will be x squared minus 16 by 3x plus 16 by 3. Multiplying by 3 in order to remove the denominator 3, we get 3x squared minus 16x plus 16 as the required quadratic polynomial. If alpha and beta are the zeros of the quadratic polynomial x squared plus 8x plus 6, we have to form the quadratic polynomial whose zeros are 1 upon alpha squared and 1 upon beta squared. For the given quadratic polynomial x squared plus 8x plus 6, we have sum of zeros alpha plus beta equals minus b upon a. Here b is 8 and a is 1, so it will be minus 8. Product of zeros equals alpha beta, which is c upon a. C is 6 and a is 1, so it will be 6. The new zeros of the quadratic polynomial are 1 upon alpha squared and 1 upon beta squared, which have been given in the question. Sum of these new zeros will be 1 upon alpha squared plus 1 upon beta squared. That will be beta squared plus alpha squared upon alpha squared beta squared, which will be alpha squared plus beta squared upon alpha beta whole squared. We have alpha plus beta whole squared equals alpha squared plus 2 alpha beta plus beta squared. We write alpha squared plus beta squared, this one and this one, equals alpha plus beta whole squared, which is this, minus 2 alpha beta. This goes to the left hand side, so it becomes minus. So in place of alpha squared plus beta squared, we can substitute alpha plus beta whole squared minus 2 alpha beta and write sum of zeros equals alpha plus beta whole squared minus 2 alpha beta, which is this. We have already found out alpha plus beta equals minus 8 and alpha beta equals 6. We will substitute these values and find the sum of zeros as minus 8 whole squared minus 2 times 6 divided by 6 whole squared. It will be 64 minus 12 divided by 36, which will be 52 upon 36, and we get sum of zeros equals 13 by 9. Product of zeros will be 1 upon alpha squared into 1 upon beta squared, which will be 1 upon alpha beta whole squared. That will be 1 upon 6 squared, because we have alpha beta equals 6. So which will be product of zeros 1 upon 36. We have already found out sum of zeros equals 13 by 9. Now the required quadratic polynomial will be x squared minus sum of zeros into x plus product of zeros. We will substitute the values and write x squared minus 13 by 9, which is sum of zeros, into x plus 1 upon 36, which is product of zeros. To remove the denominator, we will multiply throughout by 36. It will give us 36x squared minus 52x plus 1, which is the required quadratic polynomial. So, in this video, we have discussed how to form a quadratic polynomial with the given zeros, and we have solved some problems based on alpha plus beta and alpha beta. In the next video, we will talk about division algorithm for polynomial. If you like this video, please click the like button, share this video with your friends and relatives whose children are in school and colleges. Subscribe this channel to get more videos of this type. Thanks for watching. Keep watching Number Collage. Thank you.